Ja, heute meine meine Rundtour in Frankfurt war sehr kurz, weil diese Wetter, es ist nicht angenehm. Es gibt ein kleines Wind und das ist kalt und ich hatte nicht die korrekte Kleidung. Das Wetter ist nie immer schlecht, nur Kleidung ist. Und ich hatte diese schlechte Kleidung. So, deswegen meine Trip bekommt ganz kurz. Aber ich habe einige Dinge gefunden. Ein Zugspielzeug für meine Enkel. Es ist eine echte Dinge, aber deswegen das ist ein sehr stabil und kann nicht brechen. Geben man Enkel einen Eisenbahnstange, so ob das ist zu lang, so machen sie diese Kurbel und ob es ist zu kurz, so verloren sie diese. Okay, so das ist wie Kinder diese Dinge haben. Dann 2 Dosen diese Schneideplatte. Das ist nur ein ganz gewöhnliches Ding. Und dann für meinen Nachbar, welcher hat meine Maschine in seiner Halle momentan, und ich denke, es hatte mir eingangs gesagt, dass es benötigt größere Bohrer. Also, diese ist das ist MK 3, glaube ich, ja, das ist 3. Und lang genug, so es gibt vielen Platz für diese Schleifen, so das ist eine lebenslange Dinge. Und dann ein bisschen größerer, das ist MT4 und es ist 38 mm. Ja, es fragt über größere, so es gibt größere. Und dann diese ist die kleinste für meinen Nachbar und das ist nur eine ganz gewöhnliche Dinge, kein Panik da. Und dann es gibt noch mehr eine Enkel, welche hat kein Geschäft von mir und nun habe ich ihn eingefunden. Es ist immer so, wenn man hat seine eigenen Kinder, so gibt man nicht diese Kinder geschenkt, welche macht laut Klange. Aber wenn es gilt diese Enkel, so dann kann man Dinge geben, welche hat eine Klange. Und diesmal, das ist eigentlich nicht ein Spielzeug, aber es ist ein echtes Hochner Piano, Harmonika und Melodika heißt das. Ja. Und es ist, ich glaube, nie immer gebraucht. Es ist alt, aber nie immer gebraucht. Es hat seine Originalverpackung mit all diese Kunststoffdinge da rein. Und es macht seine Klange. So, diese waren meine Gefunde im Flohmarkt. Nun muss ich nach Post gehen und danach mache ich eine kurze Video über meine Pläne für die Elektrizität-Dinge in meine Fräsmaschine, weil sie haben diese alten Motoren und so weiter. Aber ja, nachdem ich habe Post besucht. Hallo, zurück von den Post. Ich habe auch geschlafen und Essen und alles Mögliche machen. Es ist Sonntag nun, der nächste Tag. Und ich habe mich ein bisschen vorbereitet für diese Präsentation von den elektronischen Änderungen in diese diese Fräsmaschine. Und ich soll nicht diese Präsentation in Deutsch ausführen, weil meine Wörterliste ist kurz in elektronischer Terminologie. Es gibt eine bessere Präsentation in Englisch. Und es ist auch so, dass meine Deutsch ist so schlecht, dass es sollte ganz unverständlich sein. Trotzdem ja, es ist so schlecht, dass ich kann das nicht in deutscher Sprache präsentieren. So, lass mich eine Kameraausstellung hier ersetzen und dann anfangen wir mit Englisch. So, I have been into electronics all my life, and for this reason I have a very capable hamsack with equipment for measuring and manufacturing things that I like, and in this case it will be the modernization of electronics and the electric system of this milling machine. Yes, and here you see a picture from my hamsack, and those of you who know about these things might notice that there are some quite quality equipment present here. For example, the Metkal soldering station, Weller rework station, and some other things which might be needed in electronic repair, and this is above normal hobby shop, really. So yes, and this is the reason why I feel quite comfortable on making the changes into this milling machine. So I have some experience on making setting up a variable frequency drive into this type of machines. I set up this thing into my lathe, which is a Chinese one, but it has a geared headstock. Well, the combination of VFD and geared headstock gives you a really wide range of RPMs. It gives you a lot of torque in the low speeds, and on the other hand it gives you very high revolutions in the high end if you really want that. This machine is now capable of 3000 revolutions per minute on the high end, and 10 revolutions per minute in the low end. And this low end is with full torque. So yeah, you might notice here I have been using the Chinese VFD, which is actually the brand is Huanghai, which is actually very good. The only bad thing in these, which I have noticed, is the fan, which is of inferior quality. I have changed it. There is now a magnetic bearing fan which doesn't make a lot of noise. The originals from these VFDs are really noisy, and they break soon. And one of the benefits of using a VFD, of course, you can vary your speeds, but one of the benefits which is not so obvious is braking. When you stop the machine and you don't, it's a normal three-phase driven machine without any VFDs. it will take forever to stop. And this is really not funny. In my lathe, the stopping occurs in 0.5 seconds from the full speed. And of course, when you do something like that, you have inertia in all the components. So when you are braking with the motor, it will actually function as a generator. So the energy from this braking has to be put somewhere. For this reason, there has to be a braking resistor, which is nominally this is something like 100 ohms and 100 watts. I have a few of these, and well, there will be braking resistors in this milling machine as well. Then the motors in this milling machine are old. They are from 50s, and it is my doubt, I'm quite sure that the insulation material in these motors is not adequate, it's not suitable for this kind of drives. What will happen? They short circuit, that's one thing, the insulation breaks up and then you have a short there. And after that, it doesn't take long, you get the factory smoke out of the machine, and after that you will be enjoying a motor change. So it's better to change the motor in advance. This is an example of a bad motor. This is the original motor from this Chinese lathe. Well, they probably used the correct insulation material on the windings, but as you can see, the windings, yeah, they are not very well done. They are just like slapped into there. There are some loose wires here and there, and all these, when you change the frequencies in this type of motor, they will start to vibrate. And everybody knows that if a copper vibrates, it will break it down. It will cut the copper wire. And for this reason I actually changed this motor into a better one, a modern one well, this is a modern motor, but it's a very badly made modern motor. And so I changed a little bit better one into this lathe. And then when there is a separate stop, start, switch and so on for this motor, this VFD, so actually the switches are not taking the full current from the motor, they are just controlling the VFD. This means that you can use low current switches in there. So this is a general schematic of the Schaublin milling machine. And as you can see, we have 3 motors here. The one in the middle is the spindle motor. It has 2 speeds, 1000 revolutions per minute and 3000 revolutions per minute. And it has, therefore it has a double winding system, which is quite complex actually, and is not very nice, because the switching of that type of motor is nothing but simple. And then on the left side you can see 3 relays. These relays are for switching on and off the motors in this system. There is one switch for the spindle motor, and then there is another switch and relay for the traversal motor, automatic feed motor, and yet another switch for the coolant pump. And on the left side you can also see a transformer. There is these two round things which are overlapping. It's a transformer. It's a 36 volt transformer for the relays only. And so this is the logical system which is behind a door on the pedestal of this milling machine. All this will be, all the things on the left side will be changed. There will be 3 VFDs, and then we will have low current wiring going into the switches. Some of the switches, like the one that is used for controlling the direction of the machine and the revolutions, is actually going to be replaced with a reed relay switch. I will publish the design later on. It's a switch that doesn't have its contacts in air. They will be in glass tubes, and if you design this type of switches well, they last forever. And they are really nice to use while there is no friction on the switch, but of course you need to have some positive indexing on the switch so that you know in which position it is. Same applies to the other switches. Then we have also some safety features in the milling machine which have to be thought over. What will we do with them? And this is what will be done for the milling machine, for this logic inside there. Furthermore, these are the motor specifications, and well, it states that, as I said, that the motor, the spindle motor, is actually it can be run in 2 speeds. One is 1000 and one 3000 revolutions per minute. And what is remarkable here is the power. The motor is only 1.6 kilowatts. This is a little bit small, I think. I will actually replace it with something like 3 kilowatts. And furthermore, I will select a motor which is 3 kilowatts, and it is 3 kilowatts on 1000 revolutions per minute. When you want to have the higher revolutions, then you just double the frequency, and there you go. It's a VFD, you can do that. What I will not do is to make it proportionally adjustable, this frequency, because this milling machine is intended to be run on certain speeds. If you run the gearbox too slowly, it might not be lubricated properly. So it has to be run on some minimum speed, which I assume is the 1000 revolutions per minute. Same applies to the feed motor for Schaublin. This is a very small motor, and I think we don't need here any more powerful motor. I will change the motors to, if possible, I will change the motors to something more modern. but I think something like 750 watts is more than adequate for this one. And yes, it will be run on the 3000 revolutions per minute, and that's it. And then we have the coolant pump, which is not stated here. I assume it's even more or less powerful, maybe only 100 watts. But in this case, I probably will make it adjustable linearly, so you can adjust the coolant flow. So yes, usually you are using a valve for that kind of things, but in this case it could also be adjusted by the motor revolutions. So this is my plan. And now let's see one more time what I will do here. So all these parts here, which are inside a cabinet in the pedestal of the machine, these will be replaced with 3 VFDs. And in this case, this is the spindle motor. The motor is quite near the pedestal. It's actually, the motor itself is also in the pedestal, so therefore the connection between the VFD and the motor becomes short. Despite everything that is connecting VFD and the motor will be put inside a copper tube, because otherwise there will be a lot of radiation, radio frequency radiation, and I don't like that. And furthermore, it's a good practice to put some shielding on these cables. And then same applies to the feed motor. I assume this one is the feed motor, maybe. So this one is must have a flexible cable, because it's mounted on the moving part. So what I will do, I will use the shower, the same thing I used with my lathe, I will use here. It's very inexpensive. It's a shower tube which you normally use in your shower, and it's perfectly good for this usage. And then this is this tiny thing here is the coolant pump, which will also have its own thing. This switch which is drawn here is a little bit, it's actually, yes, it is between the motor and the main switch, and this is this configuration. It's not good now, because this switch is actually, I think it's located on the front of the machine. I'm not, well, this might be on the side of the machine. Anyway, there are 3 switches on front of the machine, and these could be used to control the direction and speed as well from there. And of course I use the original knobs, etc. You don't notice any difference on when looking into the machine. I think this machine has a very beautiful look. I don't want to change anything on that one. And then there is also on the front panel there is a coolant pump switch and also switch for the feeds. Then we have some switches for the jogging, fast forward, fast feeds, and in this case the up down doesn't have a fast, it only exchanges slowly. This might be a result of the motor being so weak, maybe. Anyway, I will stick to that. No fast movement for that motor. So, this part of the project will involve some fabrication of specific switches involving reed relays, magnets, and well, it will be fun, I believe. For me, because I don't have any difficulties with the electronics here. It's a trip in the park for me, but it will be somewhat challenging when I do the switches and their mechanics, and maybe there are something specific which is probably missing from here, the movement limiters, so that you cannot power feed beyond a certain point. Some limiting switches there might be a really good idea. So this is what I had for you today. Hopefully you enjoyed my English. Well, well, here we are, and have a nice day and keep safe.